Today's lesson is on transformations with graphs, and we're going to be translating, transforming, moving different functions around the axes, flipping, reflecting them, dilating them, translating them, and pretty much everything you can do to a function. So the first thing here we got here is use the graph of x squared to obtain the graph of g of x equals x squared plus 2. And I think we all know most of this is going to be old hat. We already know most of this. So that moves it up 2. So here's f of x, the blue, and then x squared plus 2 is g of x, and it's just been moved up 2 units, vertical distance here. So this is x squared, this is x squared plus 2. So anytime we're adding or subtracting away from the function, so it's not within the function, then it is a vertical shift. So where would this be moved? Correct, down 3. So vertical shifts are anytime we have a function, and this is any function. If you add c, you're going to move it up. If you, c is less than 0. C is less than 0. We're still adding c, but it's less than 0, so we'll be subtracting. We're moving down whatever it is. So c is negative 3, so we're going to do the function minus 3. We move it down 3. Here it's c equals 2. We're going to move it up 2. Very easy, vertical shifts. What about x plus 2 quantity squared? Well, x squared's a parabola, so's g of x, but now we got this x plus 2. And this is where parentheses lie. Because it's within the parentheses, the plus tells us we move left 2. And again, we've already talked about these. These are called horizontal shifts. Horizontal shifts lie, the parentheses lie. So if we have h like a f of x minus 2, then it was 2 to the right instead of left. Okay? So do we have any more? Yes, we do. Here's a great one. X squared to x plus 3 quantity squared minus 2. So what's the translation? That would be left 3, not up 2, down 2. Does that make sense? This tells us left, this tells us down. So there it is. Okay, now we keep using x squared because it's easy to move around an axis, okay? Now these are really important. We haven't talked about these yet. Reflections about the x-axis and y-axis. Okay, if we take a function f of x and we put a negative sign in front, so we negate the function, we reflect it about the x-axis. So we flip it on the x-axis. So if we have a parabola like that, it would be flipped right there. There's a reflection line, the x-axis, if that makes sense. If we put the negative on the variable within the function, we reflect it on the y-axis. So let's say we had a parabola like this, then that parabola would be reflected over here on the y-axis. That may not be our best function. If we had this line, then it would be this line. So we would reflect it on the y-axis if the negative is within the function. So this is x squared in blue, but this is negative x squared in red. We flip it on the x-axis because the negative is on the outside. But if we here's root x, radical x, there's our graph. Well, then if we flip it on the y-axis, we negate the variable inside. See that? All right, so that's a reflective shift. So on this one, use the graph of radical x to obtain the graph of g of x equals negative radical negative x. Well, here's radical x. Well, this says right here, we're going to flip it on the x-axis, right? So the new one is going to be down here. That's correct, right? Yep, negative f of x reflected on the x-axis. But the one inside said, okay, we're going to reflect it on the y-axis. So the final answer then is this one right here. This is the graph that we're looking for with this function. So this is called a parent function, by the way, the original. So reflected on the x, reflected on the y. Okay? And I did yours, I did it backwards, but we got the same result, I think. Yep. Okay. Now, compression and stretches. Now, these are the most difficult ones to understand. Okay. So let's say we have a function. It doesn't matter what it is, but it's f of x. And we put a constant in front of the function. A times f of x. If a is greater than 1, it is a vertical stretch. So if you can imagine a rope, and the rope is it's got two ends, and you are holding the two ends. So say here's the ground, here you are holding this rope. Oh yeah, it looks like a parabola, doesn't it? If you vertically stretch, you are going to pull it up. And that is going to make your rope get thinner there, correct? So it's going to be a little thinner. Instead of this big loop, it's going to become more of a V. That's called a vertical stretch if A is greater than 1. Now, it's a vertical compression if A is between 0 and 1. So we're going to push it down. So if you have your calculator, it would be a good idea to experiment with that. So a good graph would be like, let's say f of x equals, x squared isn't the best. Let's go cubed. Let's do x cubed and then do 2x cubed and see how it pulls. This is the cubic. It's a chair function. It will make the chair thinner there. It will pull on these, okay? So it'll stretch it. But if f of x is 1/2, it will push them down so it's flatter here if it's 1/2 x cubed. So play around with that, and you can see if you're between 0 and 1, it's going to push it together vertically. If it's greater than 1, it's going to stretch it. Now, horizontally looks an awful lot like vertical compressions and stretchings. It's the same concept. However, if this is found with A inside. So in other words, instead of it's f of x equals x cubed, try f of x equals 2x quantity cubed. You see how the A is inside now? The constant. So this is called a horizontal compression because A is greater than 1. So if you can imagine horizontally now, pushing it together. So it's kind of the same thing as a vertical stretch, but that's called a horizontal compression. And then horizontally stretching would be like f of x equals 1/2 x cubed. It's between 0 and 1. And that's horizontally, you're going to pull it apart. Those are called compression and stretches, and the only way you can really get good at those is to practice and have some fun with it. Here's an example. You have x, absolute value of x. This is absolute value of x. Put a 2 in front. It vertically stretches, which means we're going to pull on these edges, which moves it to here, okay? Because A is on the outside. So the best thing to do is just to play with those and look at when A is greater than 1, when A is less than 1, between 0 and 1. And then you think, well, what about the negative? Well, remember, when we have a negative, it flips it. Where's that at? Vertical shift, horizontal shifts. Here. If we have a negative in front, it's going to shift it. Negative on the outside, it's going to reflect it on the x-axis. Negative on the inside, it's going to reflect it on the y-axis. And that is our lesson for transformations.